Hello everyone. This is a special occasion, and for this special occasion I decided to talk myself. Normally I let an AI voice talk, but in this video I'm discussing a topic that I made for our community, and so I thought it would be more personal if I also use my real voice. That being said, English is not my first language, and also I'm not used to talking by myself, so bear with me in moments where I stumble over my own words or I need to take some time to figure out how to express myself. Now, the project I made for our community, it is an app. It's an Android app. It's currently available in the Google Play Store, and it's called HelloFractal. I made this app because I want to give our community something to talk about. So in the future, we can have discussions about features to add to the app or existing features to change within the app. And also, I already implemented one feature. I call it the Fractal Hunt Game. And with that feature, each and every one of you can become a visible part of the app quite easily. This video serves as a walkthrough through the app, and while we have our walkthrough through the app, we will encounter situations where we briefly touch on the topic of the Fractal Hunt game, but whenever this is the case, I will mention that it is tied to the Fractal Hunt game and then won't go into any more detail about it. This is because for the Fractal Hunt game I will make a separate video, and in this separate video I will only talk about the Fractal Hunt game, about all the features in the app tied to the Fractal Hunt game, and I will also talk more about what I just mentioned about the possibility for each and every one of you to become a part of the app with this Fractal Hunt game. Let's now start our walkthrough by opening the app. The first screen we encounter is the Fractal view, and on the screen we can see our currently rendered scene. The render options that were taken to render this scene are displayed at the top left. These are options like zoom, center coordinates, iterations, color palette, and so on. There are many different ways of changing a scene. Two ways are by either sliding across the screen, which changes the center coordinates, or by pinching the screen, which changes the zoom. You might have noticed that whenever I'm sliding or pinching, there's a lower resolution render going on. I call this lower resolution render a pre-render, and its purpose is to let the FPS stay high whenever we are sliding or pinching. This low resolution render also uses an algorithm I explained in my last video, where I showcase different rendering algorithms. It uses the algorithm that only traces the boundary of each escape time area and fills in the interior pixels in one swoop over the image without evaluating their escape time. I also mentioned in that video that this algorithm can cause some artifacts, and this is true. The pre-render in this app can cause some artifacts, but I think it's a very worthwhile trade-off, because the pre-render doesn't look that nice anyway because it's just lower resolution. But whenever the full render kicks in, then each pixel is evaluated in a raw manner. So the escape time for each pixel is evaluated. So there cannot be any artifacts whenever a full render of a scene is done. To the right side of the screen we can see two columns of icons. We will now go over each icon from top to bottom and from right to left. The first icon, the cogwheel, brings us to a settings screen. There we can take many different settings which changes a scene, but I will go over them in more detail later. The second icon, the icon to the left of the cogwheel, the save icon, lets us save a currently rendered scene to our device. This is especially useful when we want to make a background image for our device, because the resolution of the saved image of the scene is already the resolution of our device. The icons in the second row are tied to the Fractal Hunt Game and are therefore not further explained in this video. This is also true for the icons in the third row. So let's move on with the icons in the fourth row. In order to showcase the flag icon and the arrow icon to the left of the flag icon, I will quickly set up a nice scene. So let's say you have a nice scene that you want to keep in mind for something. Maybe something like this. And you want to further explore the Mandelbrot, and you might want to come back to this scene later. Then you can tap the flag icon, and now this scene is saved. And now you can wander off into different areas, looking at different scenes. And when you want to come back to the scene, you can just tap the arrow that's pointing to the bottom left, and you're back at the scene you just saved. There's also a functionality that is given by the flag icon that is tied to the Fractal Hunt Game, and that functionality, as I already explained, I will explain in the separate video. In order to explain the icons in the fifth row, I want to introduce some terminology. So currently in our scene, each pixel corresponds to a different value for our C parameter in our fractal formula. And for this reason I call the scene currently rendered in C space. But we could also interpret the different coordinates of pixels in this scene as different Z0 values for our fractal formula. And in that case, I will call it the Z0 space. To change from C space to Z0 space and vice versa, we can use the double arrow icon. So if I tap the double arrow now, then I switch from C space to Z0 space. And you might be familiar with what you're seeing here. It is a Julia set. And if you're wondering what Julia set it is, because there are infinitely many Julia sets, it's the Julia set for the C coordinate, which is the center coordinate of the scene from where we left off. So when I tapped the double arrow icon, two things happened. I changed from C space to Z0 space, and in Z0 space, which is some Julia fractal, I then switched exactly to the Julia fractal we are interested in, which has as z coordinate the center coordinate from where I left off. And we can now zoom around here and look at it. And when we are done looking at it, we can tap the double arrow again. And then we are brought back to where we left off. So since we left off into Julia set from this point, when we tap the double arrow again, we will exactly be at this location again. And I made it this way because this is an easy way to see for different locations what the Julia set looks like at that location. So if I'm wondering, well, what does the Julia set look like in the Elephant Valley, for example, then I just can go to the Elephant Valley and tap the double arrow again. And now I can see the Julia set at the Elephant Valley. And tapping it again, well, let's first zoom around a bit, look at it some more, but then when I'm done and I tap at it again, I'm brought back at the same location I left off in the Elephant Valley. To explain the other icon in the fifth row, the icon to the left of the double arrow icon, the target icon, consider this. Now we are in Z space and different pixels correspond to different Z coordinates. And Z0 is currently set to 0 plus 0i, which we can read at the top left. And there seems to be no way for us to change the initial condition Z0 in Z space. And this is where the other icon, the target icon, comes into play. Because when I tap the target icon, and I do this right now, then we set our initial condition Z0 to the center coordinates we had when I tapped the icon. And for the moment, what we see looks quite like a normal Mandelbrot, but if we zoom in, we see that it is kinda distorted. And this is due to the different initial condition Z0. Also, you might have noticed that when I tapped the icon, zoom and center were reset to normal. So zoom was 1 and center was the origin. I did it this way so we can have an overview of what the new Mandelbrot with the different initial condition looks like is. And also it has another benefit. Let's just distort it in some different way by tapping the icon once again. Now it's already quite distorted. There's not much left of the Mandelbrot. And you might be wondering, yeah, but when I'm done, how can I reset it back to normal? And this is a second benefit of us getting back to the zoom 1 center equals origin kinda view whenever I tap this icon. Because that means that when I tap this icon once and then again just tap it one more time, we are back at our normal Mandelbrot. Because when I tapped it the second time, then the initial conditions were set to our center condition coordinates, but these were the origin because I just tapped it. And that way we just went back to the normal Mandelbrot with initial condition set 0 equals 0 plus 0i. And now let me go back into Z0 space. In Z0 space, the different pixels correspond to different Z0 coordinates. So it does not make much sense for an icon to change Z0 because this is dependent of the pixels. But in Z0 space, our Z value is fixed, which is, you can just read it at the top left, some number which was the center coordinates when I swapped into Z0 space. But what if we want to just change it on the fly? What if we just want to change C while we are in Z0 space? Then again, we can just use this target icon in Z0 space. And now we changed Z in Z0 space. This might not be as useful because usually you don't know if the Julia fractal for this space looks quite interesting or not, but it's always worth a try to see what's going on. One interesting fact is when we look at the double arrow icon, it is currently not yellow, although we are in Z0 space. When we were in Z0 space earlier, the double arrow always turned yellow, and when we went back from Z0 space into C space, the double arrow turned white again. Why is it not yellow now? It is not yellow now because the C value in our Z0 space is not anymore the center value of where we left off in C space. So we left off in C space by tapping the double arrow icon, but then we changed the C value in Z0 space by tapping the target icon, and therefore the new C value does not correspond to the center value in C space where we left off. And for that reason, the double arrow is now not yellow anymore. And when I tap it now, we are not brought back to where we left off, but we are brought back to some initial basic position, which is just zoom equals 1 and center equals origin. Let's now have a look at the icons in the sixth row. The lens icon in the sixth row is about the Fractal Hunt Game, and therefore I won't explain it here. The other icon, the location icon, lets us jump to a precise location. When I tap the location icon, then a window appears where I can enter precise coordinates for the center of the scene I want to render, and also I can enter a precise zoom. So let me just enter some number. Let's go with 0.25. Well, let's go with 0.26 and with 0.005 as imaginary part of our center coordinate, and let's go with a zoom of 500. I'm not quite sure where we go. We certainly will go somewhere in the Elephant Valley, but I don't know what it would look like. So let us now tap go and jump to that location with the given zoom. And yes, we are at the Elephant Valley, but we are a bit too much zoomed out for anything interesting to see. But this is the way this icon works. And if you read somewhere of a nice location within the Mandelbrot fractal or any other fractal that is supported by this app, and you want to look at this location through this app, then you just can enter these precise locations and jump there. And then you might even download it with the download icon at the top and save it as your background image of your device. Lastly, let's go over the last two icons, the icons in the last row. There's a question mark icon, and upon tapping that icon, a window pops up which explains this HelloFractal app. And the last icon, which looks like a page icon with an indication of a person, is an icon that brings us to a support screen, and I will talk more about the support screen later. Let's now go over the different render settings we can take on the settings screen. For that, let us open the settings screen by tapping the cogwheel icon. On the settings screen there are many different render options we can take. For example, we can change the color palette. Currently our color palette is set to rainbow, but we can change it, for example, to fire and see how the rendered scenes look like. They are now rendered with a fiery color palette. The color palette modifier is a function that maps the escape time of a pixel to a color in the color palette. Currently, linear is chosen, which means the escape time of a pixel gets mapped linearly to a color in the color palette. When we change it to reverse and look at the scene now, we see the scene looks now way brighter than before. So in this case, for this color palette, reversing the mapping made the image brighter. This does not always have to be the case. In fact, it is very dependent on the chosen color palette. At palette periods, we can decide how many periods of our chosen color palette we want to apply. Currently, this value is set to 1, which means exactly 1 period is applied. Let's now set this value to 4 and have a look at our scene again. Now our scene contains 4 periods of our color palette. At fractal set color, we can change the color of our set pixels. So of the pixels that we consider to be in the set of our fractal. We can change the color by sliding these RGB sliders. So let's set it to some kinda green color. And let's have a look at our scene. Now, all the pixels that were previously black because they were considered to be in the set are now colored with this green color. And now you might notice that this green does not really fit the color palette too well. And for that reason, there's this button set color fitting to color palette. And when I tap this button, then the color is set to a color that fits our color palette. When I tap it right now, the color is set to black. This is because the last color of our mapped version of our color palette is black. But if we now go with a different color palette, for example, neon lights, and tap this button again, then the color is set to some bluish color. Let's now look at our scene again. Now we see this blue fits the color palette quite nicely. The next render option we can change is color palette stretching. And in order to demonstrate what it does, let us set it to no for now. And for demonstration purposes, also I will change some more settings. So I will change the fractal set color back to black. I will change the palette periods to 1. I will change the color palette modifier to linear, and I will use the rainbow color palette. And let us now back out into our fractal view screen. And now I will zoom a bit around. And let's say I want to zoom into this 5-star. And the longer I'm zooming into it, the more I notice that it all looks quite blue and there's not really much color variety in the scene. And this is due to the reason that when we set this setting color palette stretching to no, then the escape times get mapped from 0 to max iterations to the color palette. And since we are quite zoomed in, all the escape times that are visible within the scene are quite near to each other with respect to the whole range from 0 to max iterations. And therefore they get all quite the same coloring applied to them. But when I now set color palette stretching to yes, then only the in the scene visible range of escape times get mapped onto the whole range of the color palette. And now when we back out, we see our scene is now way more colorful than before, because only the visible range got mapped to the whole color palette, and therefore the colors are spread out over the whole palette, even though we only have a very small range between minimal occurred iterations, so minimal occurred escape times and maximal occurred escape times within this scene. So I usually like the setting to be yes more. This is also the reason why it's the default setting. But keep in mind, when the setting is chosen to be yes, so the color palette stretching is applied, then there can occur some flickering when panning zooming, because sometimes black pixel, which was a pixel that was considered to be in the set, is from one moment to the next not visible anymore in the scene, and therefore the max occurred iterations drops quite a bit, and then the colors get reapplied very differently from one frame to the next. But all in all, I like this setting very much. The next setting is about using complex conjugate, and it means if we want to use the complex conjugate in our formula instead of Z. So instead of Z, we just use the complex conjugate of Z. and I can demonstrate it here. When we set this option to yes, then, well, I have to zoom out a bit because currently I'm within the set. And we can see our tricorn or mandelbar. This is the fractal we arrive at when we use the formula z equals z conjugated and then squared plus z. Let's now have a look at the next rendering option, which is the fractal type. Let us set this to burning ship for demonstration, and let us also revert back to not using complex conjugate. When we back out now, we can see our burning ship fractal, which is also a quite popular fractal. Let's zoom in a bit to see the nice structures of the burning ship. The next setting we can discuss is the landscape mode, and it has a function that is applied to the complex plane in order to morph the complex plane in some way. Normal means there is no morphing going on, which means that the pixels coordinates are interpreted as real and imaginary parts of a complex value. But let's just demonstrate it by setting it to inverted, and let's also change back to Mandelbrot. And now let's zoom out. And we can see this teardrop shape that is quite familiar with us. The next render option is about max iterations, and there we can choose between two different modes, fixed modes or dynamic modes. Fixed modes set the max iteration to a fixed value. For example, fixed 1000 sets the max iterations to 1000. Fixed 2000 sets the max iterations to 2000. With dynamic modes, it is different. Dynamic modes also set the iterations to some amount, but the amount is dependent on the current zoom level. The deeper we zoom into a location, the more iterations are used for rendering the scene. So, for example, when we use dynamic x2, which is just always double the value of dynamic x1, then we can see that currently we use 392 iterations. We can read that off the top left of our screen. But when I start to zoom into regions, then the iteration count goes up. Lastly, we can change the escape radius, which is usually set to 2.0, and it's the threshold value at which we consider the orbit of a pixel to be escaping. Usually, you can just let it stay at 2.0. This was everything about the render options. Now, let me show you two more screens. So, I already mentioned that the icons in the second row are about the Fractal Hunt game, And when we tap the right icon in the second row, so the search icon, then we enter another screen which is tied to the Fractal Hunt game, and therefore we won't go over it in more depth here. But if you are interested, there will be a second video about this topic. And the other screen I want to show you is the support screen. We were already briefly on that screen. I want to go over it now in more detail. On this support screen, under Learn and Follow, there is a link to my YouTube channel, Stromwender. And if you want to support me, you can subscribe to my channel. It really helps out quite a lot. And then under Learn and Follow also, there are 2 more links, which are links to videos about this app. One video you are watching right now, and the second video is about the Fractal Hunt game, which I mentioned several times already. Under Contact, there are 2 buttons. The first button is for reporting bugs and suggestions, and the second button is for suggesting new targets for the Fractal Hunt game. What that means I will explain in further detail in the video about the Fractal Hunt game. And under Share, you can also share this app with friends, and I really appreciate that very much. It also helps out really much. If you like this app or the videos on my channel, under Support the Dev you can support me for future updates and videos by sending me a tip. This app will include some ads, but by supporting me with any amount of tip, all ads will be disabled.